Hi, I'm Anthony Scodary, founder of Gridspace. And we're defining some more terms from the worlds of computers and AI and math, et cetera. You guys liked when we did tensor, so good news, another hot topic today. We're gonna be talking about what is an algorithm. Algorithm just means a formal series of steps that achieve some sort of desired result in a reliable manner, right? The word algorithm originally comes from a Persian scientist. It's originally an Arabic word or an Arabic name, and then it went through Latin and was adopted by Chaucer into English. But it really just means a structured series of steps that achieve a result. One of the first examples of an algorithms in any written form was the Sieve of Aristophanes. So the idea is you want to find prime numbers, and there's a lot of different algorithms to do that. But his was, so prime numbers, again, are numbers that are not divisible by anything but themselves in one, right? And so his sieve, which means like filter, right, is you just write down all the numbers between 1 and n, right? And you want to filter out the ones that are definitely not prime in that list. And so, okay, you start with, 2. 2, is prime, great. So now then take every multiple of 2. 4, filter out 4, it's been filtered out. Then the next multiple of 2 is 6. 6 is a multiple of 2, so it's not prime, filter it out. So you just cross out those numbers, right? And then once you're done going through your whole list, you filtered out a bunch of multiples of 2. We move to the next highest number that hasn't been crossed off yet, which is 3. That means 3 is prime, so we circle that. That's another prime number like 2. But now we take other multiples of 3. We get to 6. 6 is already crossed out. We get to 9. 9 wasn't crossed out. Now we cross it out. Okay, we do all that. We filtered out all the multiples of 3, right? So we've circled 2 and 3. We found 2 prime numbers. So then we move to 4. 4 has already been crossed out. We move to 5. 5 is still available. We circle it. It's prime. So then we take the multiples of 5. 10's already been crossed out. 15's already been crossed out. 20's already been crossed out. 25 has already been crossed out. Is it 20? I guess 25 hasn't been crossed out yet. Yeah, so okay, so we cross out 25. But the 15th multiple of 3, right?
Oh, yeah.
Yeah. And so we keep doing this process, right? And we circle the numbers that haven't been crossed out previously because there's no number below them that it's not a multiple of, therefore it's prime, right? And when we complete this on our list, let's say we had numbers 1 to 1,000, you've just generated all the prime numbers from 1 to 1,000. But we're following a very small number of simple sub-steps, like move to the next number, cross the number out, move to the last place where we started, move up by 1, circle that number. We're following a series of structured steps that the end result, we can not only turn the crank on in a fairly mechanistic way to achieve our result, but typically we can prove that the algorithm is correct, that it's going to generate the correct result and the full result. And a big part of the development of the field of computer science in the 1950s, 1960s, where you had people like Donald Knuth that developed the science of analysis of algorithms, where you could start to actually treat an algorithm like a mathematical object, where you would regularly analyze parts like loop invariance and parts of the algorithm that you could prove parts of, and then therefore prove the whole algorithm was correct. Now, machine learning, for the most part, is a subfield of optimization theory. It's also a subfield of AI. And a lot of its algorithms are actually numeric or mathematical algorithms that are about optimizing something, right? So algorithms about, similar to like if you were trying to simulate the motion of an object or trying to optimize some sort of schedule where you have some sort of target and you're trying to optimize it. We've talked about things like backpropagation, which is one of the fundamental algorithms used in AI. But a lot of these algorithms are What was I saying? Oh yeah, so anyway, they're mostly mathematical numerical algorithms, which is just one subset of algorithms. We also often regularly are processing audio, where you have algorithms from digital signal processing like FIR and IIR filters, the FFT, and these are other examples of primarily numeric algorithms. But you also have a wide class of algorithms for manipulating data structures like sorting or searching or organizing data, or proving something about data, finding some special element in a data structure. And it's probably one of the foundational fields of computer science, the first that I think was really made rigorous. And as we move into the future of AI, we're continuously finding new numeric methods that not only are impacting machine learning, but also fields like differential equation solving and physics simulations. And so it's a great time to be alive. Too bad the Persian scientist who invented the term, he's been long gone. He's not going to see it. Is this all right, Nick? Is there any errors?
Would people misunderstand that like algorithms on sound is fundamentally different from numeric algorithms for some reason?
Oh, right, yeah. So when we talk about sound, we mean computer sound. So like sampled digital audio, or specifically audio that comes in through a sensor and then is digitized using an analog to digital converter. So we're actually in like the flight path for LAX. Like we're in the pattern for LAX.
Perfect.
Yeah, so what are you gonna do about it? If you want us to find what cryptocurrency is, what Ethereum is, what Bitcoin is, what Dogecoin is, if you want to know what a wallet is, if you want to know what a smart contract is, we're not going to define any of those. But if you want to know more terms just about algorithms, like algorithmic complexity, we'll do it. You just have to put it below and then obviously, pay us some sort of crypto.